Hey guys, welcome to yet another video by Intellipaat. In today's video, we'll be learning about what is Docker. Now before we get into it, make sure you subscribe and hit the bell icon so that you don't miss any future updates from us. Okay, now let's take a quick glance at what the agenda for today's video will be. So the first thing we will learn is, why do we even need to use Docker in the first place? What are the issues that it helps us to resolve? Second, we will go ahead and understand what Docker actually is. After which, we will go ahead and understand how to install Docker. Then we will learn what is a Docker lifecycle. And finally, we will talk about a few Docker commands that will help us to work with Docker. Also guys, if you're looking for end-to-end training in Docker, we do provide the same. For any further details, check out the description below. Okay, now let's go ahead with the session.
Why do we need Docker? So guys, Docker was essentially a need which came out of, so imagine yourself as a developer and probably you're just creating a website on say PHP, right? So if you create a website on PHP, the first thing that you would do is write some code. Now when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third-party applications, the third-party libraries that you would be including in your code, right? So the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else. Right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code. Right? So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system. Right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still, they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base, etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it and he installed the PHP software. He installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. I mean, if you think about it, it was actually nobody's fault, right? The operations guy did what he could in the best of his ability to replicate the environment, but it didn't work out. Now, you guys might argue that why don't we, use VMs in this case? Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? I mean, that is a viable solution. But the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it'll become inconsistent with what other developers have.
Quick info guys, if you're looking for end-to-end training in Docker, we do provide the same. For further details, check out the description below. Now let's continue with the session.
Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable. We needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container and he can just see if the code is working properly according to what has been specified or not. Right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. What is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. That is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you have installed the container engine, you can run any type of container that is there in the repository on the or on the web, which is available. For example, if your code needs an Ubuntu container, right? All you have to do is write Docker run Ubuntu, and what would it do? It would basically download the Ubuntu container, Then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs when we compare it to the Ubuntu operating system? It's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right?
Quick info guys, if you're looking for end-to-end training in Docker, we do provide the same. For further details, check out the description below. Now let's continue with the session.
It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed. What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in there in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, that is it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay. So if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software. And on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries. And on these, you basically just put your code. In my case, I will put my PHP code on top of the container, and that would be app1. And there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay. So this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it, right? So you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system. And this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present. But in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Right. So because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right?
Quick info guys, if you're looking for end-to-end training in Docker, we do provide the same. For further details, check out the description below. Now let's continue with the session.
Now, you again, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also, one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we have, we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. All right. So guys, this was the basic difference between a Docker architecture and a virtual machine architecture. See how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on. You could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to go along with the video as we are performing the hands-on. All right, so if you're on Mac guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac, and once you have the Docker toolbox, it basically install everything. It will install Compose, it will install the Docker software, it will install the other components of Docker, so you don't have to worry about what component is what, but basically just go to this particular link, download the Docker software, and once you have the Docker software, just come back to this CLI and this just pass the command Docker version, and if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm going to do is I'm going to just go back to my terminal so that we can use the PuTTY software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. All right, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. right? So if your internet is fast, it'll hardly take a minute to install Docker. And once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's docker hyphen hyphen version, and as you can see that the Docker version is 18.061 CE, and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So we have installed Docker on our system, guys, and I hope you guys are also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back, because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on, so that you get the maximum knowledge possible from this session. Docker container lifecycle. So this is the whole life cycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start, or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository, right? So that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub, right? So the first thing that you do is pull an image from Docker Hub onto your system. And this is your system where Docker engine is installed. And basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image. And the moment you run an image, it becomes a container, right? So you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, you that is again a life cycle state that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the life cycle of a container. The first thing that you do is you pull it from Docker Hub. It becomes an image. Then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. Common Docker operations that you would be doing when you are working on Docker in your day-to-day life. So this is the first command that we can try out when we are working on Docker. All right. So whenever you want to find out what version of Docker that you're working on, you can simply pass this command Docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal because I feel that this color is a little dull. So that it becomes better for us to see. Just give me 1 second. All right, much better. So when we pass this command Docker version, you get the Docker version, the current Docker version that installed on your system along with the build name. And this is exactly what this command does. All right. The second command that you can go ahead and try is Docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. All right, so what and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull Ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. All right. Okay. So we'll type in docker pull and then the image name. So this is the image name and we'll hit enter. All right. So sorry about that. I forgot to use sudo. All right. So sudo docker pull Ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now, remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that. So sudo docker images, and then you would be able to see the image that you just downloaded. Okay.
Quick info guys, if you're looking for end-to-end training in Docker, we do provide the same. For further details, check out the description below. Now let's continue with the session.
So this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on, is I think around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is -it, which basically means make the terminal interactive. -d, which means run the container as a daemon, run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what -d does, right? So the command would be sudo docker -it. It means make the container interactive in the terminal so that I can also pass in commands. -d, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see docker ps would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container, right? So this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run -it-d and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then -a. And with this I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago, and this is the container which has exited, which we manually stopped, and we can see that also by passing the command sudo docker ps -a. Okay, now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps, All right, so this is the container ID. This is where this is the container which is currently running. Now, if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then -it, make it interactive, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now, if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says, okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I passed the command sudo docker ps, and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right, so if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running. So if you do a docker ps, you can still see the container running in your docker ps space. Alright, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. Alright, okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay. You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet, right? So if you have the stopped the container, but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the life cycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm, and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps-a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. All right. Moving forward, now what to do when you have to remove an image? Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID. And this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. So this is how you can remove image from your system.
Quick info guys, if you're looking for end-to-end training in Docker, we do provide the same. For further details, check out the description below. Alright guys, this brings us to the end of the video. If you have any queries, leave them in the comments below and we will get to you at the earliest. Thank you for watching.